Okay, in today's video, we're going to look at standard form, or sometimes it's called scientific notation. And basically, it's just a way of writing big numbers or small numbers. Now, in our everyday life, we don't really use this. We usually try and use units. So if I said 1 millimeter or 1 kilometer, then I kind of use this unit to tell me how big or small a number is. But sometimes the units, they kind of don't help us. So for example, I had this and it was kilometers. Okay, sure, there are bigger units than this. But the point is, if I had this very big number, like every day, it's easy to maybe notice that's 1,000 or 1,000,000. But as soon as it gets bigger and we get these big numbers, then it kind of becomes tricky to figure out like how big is this number really? And in standard form, it's kind of quicker to see. So what is standard form? You should have an idea of what indices are or what an index is. So basically, it's writing a number in a certain way. So let's say I wanted to write the number 1,000. I could write that as 1 times 10 to the power of 3, because 10 to the power of 3 is 10 times 10 times 10, and that is 1,000. And that would just be 1 times 1,000. So it looks like, okay, but why would we ever write this? Now, the answer is I wouldn't really write 1,000 in standard form. I'd usually write bigger numbers. But to understand the principle, we're going to start with smaller numbers first. And in your IG exam, they'll usually just give you smaller numbers. So let's just take a look at what standard form is not, because there's a certain couple of things that's important for us to know. So when I have something like standard form, let's say I'm going to write a couple of numbers here. Something like this. Yeah, we can even have negative numbers, bigger numbers. Okay, so I wrote four examples here, and only actually one of them is in standard form. So standard form is when I only have one digit here in the units position. So this unit has to be 1 or 1 to 9. It can be, let me write another example of what it's not. So this is standard form because I have only one number there, followed by the decimal and some other numbers, times 10 to the power of something. So this part is still fine. This part is not standard form because I have 2 digits. This one is also not standard form because there are 2 digits. This one is not standard form because there are 3 digits. In this case, there is a digit, but it's a 0. So it needs to be between, well, bigger than 0 and smaller than, well, 10. So basically 1 to 9 counts. So this is standard form, that's not. But we can rewrite this in standard form, but I'm not going to do that. I'll do that in a later video. First, let's just do some basic examples. Okay, so let's get a couple of numbers. Let's make a big number like 1, 2, 3, 5, 9, 0. And they're asking us, hey, write this number in standard form. Now for standard form, I only need one digit in the front, and then basically the decimal place is right there at this point. And I want to move it to there because standard form would look like 1.2359. I don't worry about the trailing 0 because it doesn't really matter. Times 10 to the power of something. Now I don't know what that something is, and in order to find out what that something is, I have to figure out how many times did I have to multiply by 10. So in this case, it was 1, 2, 3, 4, 5 times. Okay, and if you were to take your calculator and you wrote 1.2359 times 10 to the power of 5, or times a 10, with 5 zeros, because 10 times 10 times 10 times 10 times 10 is going to be this 100,000. If I multiply this out, then you'll see, okay, well, this is going to move 1, 2, 3, 4, 5 times. and then I'll end up with this number 123,590. So this is when I want to make you can see this is a big number because this is a positive indice or a positive index. And yeah, if I had 2.39 times 10 to the power of 7 and 9.43 times 10 to the power of, I don't know, 12, it's really easy to see which number is the bigger number. In this case, this is obviously the bigger number. Both of these are in standard form because there's only one digit in front of the decimal point. Okay, they can also ask us to write this in expanded notation. So then it's when I'm taking this number, for example, and I want to write it as, with the actual number. Then I'm gonna write the 239, and in this case, I'm seeing the decimal is there, and it's going to move 7 spaces to the right. So it's going to move 1, 2, and then another 5 times. So no, it's going to be basically 5 zeros. So because there's 1, 2 digits behind the decimals, and I know there's 7, it's multiplied by 10 to the power of 7. I know there's going to be 5 zeros behind it. In this case, if I wanted to write that one, let's just I'm writing all over the place here. Sorry about that. In this case, I'm going to do 493, and it's 12 zeros, but I'm already using 2 just to get to here, so it's just going to be another 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But you can see now why we use standard form, because this is a very, very big number. Okay, let's say I wanted to make, if I had a really small number and I wanted to write it, what would that look like? So let's just rub this off. If I had a really small number, let's say 0.0000, I had one there, but anyway, 0.337. And I wanted to write this in standard form. I want to have the 3 in the front, followed by a decimal and the 37. So basically, I want the decimal there, but the decimal is currently here. So it's going to have to move 1, 2, 3, 4, 5 places. So it's times 10 to the power of 5, but not 5, because if I multiplied this number, this 3 times this, 10 to the power of 5, I'm going to get a very, very big number. So I'm basically dividing this by 100,000. So I have to make the little negative there. So in this case, if I looked at the top number here and I wanted to write this in standard form, it's going to have to be 1.23. So the decimal should kind of be there, but it's currently here. It's going to be times 10 to the power of negative something, because I'm making a small number bigger. And now I just have to count. 1, 2, 3, 4, 5, 6, 7, 8 jumps. And there you go. In the next video, we're going to look at when we kind of add and subtract or multiply these kind of big numbers.